Hello, Algebra 1. So today we're going to be looking at writing equations in point-slope form. And so to kind of start things out, we've already looked at slope-intercept form, I believe, which is y equals mx plus b. And this is a different format, okay? It turns out slope-intercept form is nice to use when you know the y-intercept and you can calculate the slope, but you don't always know the y-intercept. And so there's another way to start out writing equations of lines, and often you'll start out in point-slope form and then rewrite it in slope-intercept form, okay? And so what's interesting is the point-slope form is kind of messy looking. Okay, it's kind of gnarly looking. Something that might help you to remember that these are minus signs is it turns out this is just the slope formula rewritten. M equals y2 minus y1 over x2 minus x1. It's just rewritten, and they left an x and a y as variables. And so it's still going to have the x and the y as variables. You know, they can be lots of different things, but then these, when you use a specific point, you'll be able to fill in and a specific slope, you'll be able to write a unique line, which is cool. All right, so yeah, m is the slope, and then x1, y1 is just a point through which the line passes. Okay, so let's see this in action. Write an equation in point-slope form of the line that passes through the point -8, 3, and has a slope of 1/4. Again, you don't have the y-intercept, so you can't do y equals mx plus b. You don't have the y-intercept. At least you can't easily use it. But you can do point-slope form, so write it out. Y minus y1 equals mx minus x1, okay? I often don't write it out, but I have it memorized. So if you don't have it memorized, you're probably going to want to write it a couple times to make sure you have it figured out. So what you do is you go y minus, and then you fill in the y value of your point. It's 3. You plug in your slope, 1/4. Parentheses, x minus, and then you plug in the x value of your point. So because they asked us to write an equation in point-slope form, we're basically done. You commonly see people simplify it just a bit and change this to x plus 8. And that's point-slope form. So if you have an equation written in point-slope form, you can easily get a point from it. So it'd be opposites. It'd be -8, 3 is the point, and then the slope's 1/4. You could actually graph from that. Okay, so for example 2, using 2 points to write an equation of a line. Now be careful here, they're specifically wanting slope-intercept form. So they're going to want us to write this as y equals mx plus b, but we don't have a y-intercept. So what we're going to do on this problem is we're going to start out by using point-slope form, and then we're going to rewrite it in slope-intercept form. But we've got another problem here. We've got 2 points to choose from, so we're going to be able to fill in x1 and y1, but we don't have a slope. So what we're going to do first is we're going to solve for slope. We're going to subtract the y's on top. I'm going to do -2 minus 2. Since I did that, I got to do 3 minus 1. And I get the slope to be -4/2, which is -2. And now I'm ready to write an equation. Y minus 2 equals -2x minus 1. That's point-slope form. Notice I could have done this other point, and actually I would encourage you, if you haven't already written this down, try it with the other point. We're still going to end up with the same answer, which is fascinating, all right? So now we're not going to stop here because this is point-slope form. They want it in slope-intercept form, so we got to get y by itself. Before we do that, let's distribute the -2. Then add the 2 over. And slope-intercept form is y equals negative 2x plus 4. And the cool thing is if we had used 3, negative 2 instead, we would have gotten the exact same answer. And I'm totally serious about that, okay? So right here, we were converting to y equals mx plus b. Okay, all right, so let's turn it over, try some more. Write a linear function f with the values of f of 4 equals negative 2 and f of 8 equals 4. Well, when we learned how to calculate slope, we realized that these are just coordinates in disguise. Inputs 4, outputs negative 2. Inputs 8, outputs 4. So we're going to have to calculate the slope. I'll go 4 minus a negative 2, 8 minus 4. That'll get me 6 over 4, which is also 3 over 2 if you reduce it, which you should. And then from there, I'm going to pick this point right there. I would encourage you to try the other one just to see that we will end up with the same answer. We are going to go ahead and get it in slope-intercept form because they want us to write a linear function. So we're going to have f of x. We need to replace y with f of x. So we are going to have to get y by itself, it turns out. All right, so I'm going to go y minus 4 equals 3 halves x minus 8. Distribute this because we got to convert it. That's point slope form. Now we're going to convert it. And you can use a calculator to do that if you'd like. I did it in my head. 8 divided by 2 is 4, and then 4 times 3 is 12. And then we add the 4 over, get y equals 3 halves x minus 8. Now that's not quite the final answer. We should replace y with f of x. And that answers the problem completely. Okay, so this next one's kind of interesting. We're going to write a linear model that represents this relationship here. It says student council is ordering customized foam hands to promote school spirit. The table shows the cost of ordering different numbers of foam hands. Can the situation be modeled by a linear function? Explain. If possible, write a linear model that represents the cost as a function of the number of foam fingers. So this is essentially going to be our y and our x. We'll have cost as a function of number of foam hands, not fingers, hands. All right, so we've got this data here. First things first, that we need to determine if it's linear or not. To be linear, it's got to be consistent addition or subtraction across here. And it is. At the same time, it's got to be consistent addition or subtraction down here. And it is. So this is linear. It was consistent addition. But then from there, now that it's linear, we've got to write a model for it. Well, class, here's what's kind of interesting. We've actually got slope right here. This is rise, this is run. Our slope's going to be 12 over 2. Now, if you wanted to, you could pick any 2 points and calculate the slope, subtract, but you're going to get 12 and 2. And so, yeah, our slope's totally 6. And what that means is that every time the price goes up 6, we get 1 more foam hand. So each foam hand is adding $6 to the cost. Okay, so we kind of have some idea of what's going on here. But now I'm just going to pick this point right here, and I'm going to write an equation for it. So y minus 34 equals slope x minus 4. And I'm going to distribute it so that we can get it into slope-intercept form, because we could have used any of these points. So I want an equation that matches everybody else's. Add the 34 over. And there we have it. So this is the cost, and this is the number of foam hands. Yeah. So what I'm thinking is that 10, that could be like maybe if they're shipped, you have to pay $10 shipping and then $6 for every foam hand. Or maybe they had to design it, so they charged you $10 to design it and then $6 for every foam hand. Yeah. All right, well, thanks for watching. Have a good day.